Welcome to the GMS MODFLOW Grid Approach tutorial. There's more information in the printed edition not covered in this video. This video is meant to just guide you through the process of the tutorial without going into the details as of why. So to start out, we need to edit the units and make sure the length is in meters and the time is days. Everything else doesn't matter. Then right-click in the Project Explorer and select New 3D Grid. And for the X and Y dimensions, change the length value to 22860 and the number of cells to 15. Then in the Z dimension, change the number of cells to 3. We will change the length later. Make sure the layer is layer 1. Then right-click the grid icon in the Project Explorer and select New MODFLOW. Select the Packages button and click the Drain, Well, and Recharge package. And then change the solver to strongly implicit procedure. Then click OK, and then click the top elevation button. Click constant to layer on layer 1 and enter 60. Then click enter. Click OK. Then go to bottom elevation and go to layer 1, constant to layer, enter -45. Then go to layer 2, enter a value of -120, and layer 3, -215. And exit both of those dialogues. Now let's get a side view. And so we can see this better, we're going to increase the Z magnification. Go to display options. On the left, we'll change it to 15. Now, make sure we are in column 1. So you can either go to column 1 or highlight it and enter 1. Now that we are in column 1, you can also tell by the IJK down here, we're in column 1. Select the top 2 layers. Right click and select Properties. Then in the I-bound, select Specified Head. Click OK. Then return to top view. So to keep going, we need to adjust the layer property flow package. So go to MODFLOW and select LPF and select hydraulic conductivity. Make sure we're in layer 1, select constant to layer and enter 15. Now, since we're here, we will also enter in the hydraulic conductivities of layers 2 and 3. So go to layer 2, constant to layer, and it's 0.9. Then layer 3, constant to layer, and 2. Now go to vertical anisotropy, and for layer 1, select constant to layer, and it's 10. For layer 2 and 3, it's 5. Then click OK for the LPF package. We're going to go to the recharge package, so go to MODFLOW optional packages, click recharge. Leave everything as default, which is the highest active cell, and select constant to array and it's 0.0009. That's 3 zeros and a 9. Then click OK, and OK to get rid of the recharge package dialog. Now we are going to insert the drains. So we're going to drag a box around a few cells in row 8. So make sure we're in row 8. It's 2 through 10, so about there, and that is 9. So I hit Shift, and we got 10. Now right click and go to Sources and Sinks, and then go to Drain and click Add BC. The conductance for all of them is the same, so enter in a value of 7430, hit enter. But the elevations are all different, so just follow me with the elevations. It's 0, 0, 3, 6, 9, 15, 20, 27, and 30. Then click OK, and the drains are done. Next, we've got the wells. To set up the wells, we're going to use the Shift key again. So click the cell just before your last drain, and that should be 910.1. The IJK is 910.1. Then hold Shift and select every other. Okay. Right click one of the selected cells, go to Sources and Sinks, and these are wells. So go to the Wells tab over here and click Add BC. These all have the same flow, and that is -12, 23, 0. And click Enter and click OK. Now we also have different wells in layers 2 and 3. So go up here to the top of GMS and go to layer 2. We've got 2 cells, row 4, column 6, row 4, column 6, and row 6, column 12. There it is. Hold Shift, click, right click, Sources and Sinks, Wells, Add BC. Both flows are the same. -12, 23, 0. Select OK. Go to layer 3 and select row 5, column 11. Right click, Sources and Sinks, and it's got a flow value of -0.15. It's really small. Now go back to layer 1. So at this point we are done with the MODFLOW simulation. However, we are going to make sure that everything is in order. So we're going to click MODFLOW and check simulation, and we're going to click Run Check. Now there may be some warnings, but we want to make sure we don't have any errors. And I don't. If you have any errors, you can click it and address it, and look back at the PDF or this video to be sure you've done everything correctly. So at this point, I'm going to save this and run MODFLOW. So I'm going to click this Run MODFLOW command. I'll click Yes to save it. Save it here. Override it. It launches MODFLOW automatically. Once it's done, it'll read very quickly. Click Close, and it reads in my head dataset from my solution. Now to change the contours, to make this a little bit more fluid, we can go up here to the contour options. Instead of block fill, we'll do color fill. And be sure the legend is on, and we'll click OK. That changes it, that everything flows very nicely. It is also possible up here in the top right corner to have some cells flooded, and you will have a little triangle, and that's totally okay. The water table is really high up here, and it happens sometimes. And again, it's totally high. It's at 65 in some places up here. Um, in fact, at the top right cell, we can see our value is 62.4, and is actually above the top elevation of 60. Something else we can do is we can utilize the flow budget in MODFLOW, and we do that by using zones and the zone budget command. So by default, everything is in zone 1, but we're going to switch to layer 2 and select everything, and change this to zone ID 2. So right click and select properties, and then under the bottom at zone budget ID, enter 2. Then go to layer 3, select everything, properties, and enter zone budget ID of 3. Now what this does, if we go to MODFLOW and click flow budget, it brings up this, but if we click the zones tab, we can look at the flow budget by zones, and in our case this is layers, and we can see zone 1 to zone 2, zone 3 to zone 2. We can see the interaction there. You can also select all zones, and then they all show up in a scrollable menu.